All right, so today I'm going to walk you through how to do lab 1. I'm going to record it, so if you need to go back and look at it, it'll be on my YouTube channel, hopefully in a couple of hours. I know it takes a little bit of time sometimes for the videos to process. So I'm going to start from the very beginning and walk you through all of it. The only difference will be is these machines already have idle installed on them. So the portion where it's installing idle, I'm going to walk through some of it, but we're not actually going to install it because it's already on there. If you have your laptop with you and want to try to install it, I will do my best to help you troubleshoot problems. If you have a Mac, we'll cross our fingers really hard and hope that I can help you. I'm not that good at it. Sound like a plan? I know some people have already started turning in assignments, and that's fine. You can get ahead of me. I don't care. But if you don't want to get ahead of me, this is the plan moving forward: is lab in class. Friday, I'll answer questions individually. All right, so if you go to the main page for this class and go to content, go to this week, and scroll down to lab 1, the PDF will open with the directions in it. Right? Good morning. Everybody good with that? Can we find the PDF? Or change the date right on the top, so we have to clarify that. Everybody good? Go ahead and drape your closet, Sasha. All right, so what I usually do myself when I get a project guidelines or work order or assignment is I read through it first, and I strongly suggest that you guys do that too moving forward. It goes back to that whole planning and algorithm thing. So the objectives are up here at the top. This lab is going to help you get Python installed or show you how to use the virtual machine. You'll be able to execute Hello World in Python. And if you didn't know this, Hello World is just about the first program you write in every programming language when you're taught a programming language. We're going to understand the difference between the Python shell and the executable file, basically what we're doing on the screen versus what we're going to turn in. And we're going to be able to submit our file to CourseDen. So hopefully before we leave, you all will have submitted lab 1 and it will be ready for me to grade. Right? Questions so far? All right, so if you scroll through this, you'll note that the labs are extremely detailed. Almost every step you need is in this lab. Also, the grading down here at the bottom is laid out for you. So if it is not submitted and doesn't run at all, you're getting no points. I can't grade it if it doesn't work, right? At least a little bit, right? If you're missing major functionalities, but you got something that ran, you're going to get at least 4 points. These are out of 10. These are only 10-point labs. It's mostly functional. You're missing some minor things. You got an incorrect file name. I am going to be very, very specific about your file names. I have 92 Python students this semester. You need to follow the naming conventions very carefully where I give you credit for your work, and I'm not trying to guess whose work is whose. When I have 20 students, I can kind of investigate and figure out the one with no name on it. 92, I don't have that kind of time. If it works 100% correctly and I run it and it's great, I'm just going to give you 10 points and go. Everybody's going to get 10 points because we're going to do it together, right? All right. So back to the top. And let's talk about downloading this. How many of you need to download Python at home still, or plan on downloading Python at home still? So I was going to tell you, I have been informed that it is not going to work on tablet. The V Lab is going to be your friend. Chromebooks may or may not. If it works, great. If it doesn't, the V Lab absolutely will. And there's a link in the announcements to the virtual lab that you can use that link to go log in, and it will simulate the Python on your computer without actually installing it. So if you need to download Python, yes, this says 3.85 because I haven't updated it. Use whatever the latest version of Python is. I think it's at 3.10 something at this point. If you have an older version, it'll still work because we're just doing the basics. So if you go to the link in the PDF, it will take you to the Python page. And the button is the very first button you see to download it. I'm not going to click the button because we don't want to double install it onto the lab machine. But you would click this button and follow the prompts. It's going to download an executable file, and you're going to execute it. Right? Back to my PDF. Where did that? Oh, too many screens. All right. So once I do that, you should be able to open it up, and it should have installed idle when it did that. On these machines, you can very quickly get to idle by just typing it in the search bar down here and open it up. And it looks like this. Right? Yes. So if you get to this window, you've got it running. Okay? So this is the shell. It even says shell up here. You can do a few things in here. Like you can test Python code. I can type and it does something. You can't see it, but it does something. So we're not going to do a lot in the shell. We always want to make sure that you have opened and created a new file, a Python file, because you want to be able to submit it to me. Because you like to get graded for your work, right? I have had students in the past do their entire lab in this shell, and it will work to a point. And then they send me a screenshot because they can't figure out how to save it. Well, I can't run your screenshot. Generally, the first time you do it, I'll try to send it back to you and say, send me the correct file. That may not be as easy this time because there's 92 of you. So let's follow, we're going to follow directions really carefully. So we started it, we got this shell. We can do all of this code here in the shell. And this is a PDF, so you can't actually, can you guys in the back actually read what's in this white window? I got one nodding yes. Yeah. So I'm going to go into the options and make it bigger. So there is an options panel, so you can change things. So you can make the fonts bigger. I think there's a dark mode if you're like me and you prefer to have it and put it on a darker background instead of dark white. But you can play around the options on your own computer and make it whatever you want it to be. So See if I can get two windows side by side here for a minute. So if I look at this screenshot here and I type in what I see on the screen, I can show you that number log was not on. 2 times 3 equals 6, right? It did what I asked it to do, proves that it works. I can't get back to that command unless I type it in again now. All right, so if I do print and hello world, it prints out the words inside the quotes. Does that make sense? So we're going to be playing with just some simple commands. We're going to print into the screen. We're going to do some math. We're going to ask the user to give us their name, that sort of thing. Input statements are asking for input. So if I do input, enter your name. What this command is saying, I'm asking the user to input, and whatever is in the quotes inside of here is what's going to be displayed to the screen. So it's going to throw a prompt up that says to enter your name, and the cursor is going to flash next to it. And the program is not going to do anything else until you type something in. The cursor is just going to sit there flashing, waiting for you. So if I do that, cursor is flashing. Right. Now, notice that there's no space between the prompt and what I typed. If you want it to be pretty and put spaces in there, you have to put a space in the input line before the exclamation point, before the quotation mark. So you'd have to put a space in right here. It won't let me edit in this window. So you know you're in the wrong window if you can't go back up and edit a line. Right? All right. So has everybody got idle up on their computers? Does everybody want to try one or more of these commands? Not working on that one at all? Type idle and yeah. If you do the V Lab, it won't be on 3.10 because ITS hasn't caught up with us yet. 3.10 just came out, so use whatever the highest number is. I think it's 3.9. We also have an option for 3.8. Either one will probably work, but I usually just go with the newest version because it's got the bug fixes in it. Anybody else having a problem getting to? Okay. All right. So we've put in, and everybody has tried a line of code, right? Look, you wrote your first Python code. Try to yourself. All right. So now, instead of, I basically have done all of these commands for you. So the rules of Python programming, we talked about those conventions we talked about, especially with naming our variables, are that you have to follow those formatting rules. So tabs are going to be very, very important in this class. We're going to tab over lines a lot. You cannot use the space bar to do this. You need to use the tab key when we start doing indentations because they have to be exact all the way down your programs. And some of you later are going to say, huh, she gave me a doc instead of a PDF. I'm just going to copy and paste the examples into my code. That's great, except Word docs have a lot of formatting in them, and sometimes they won't copy correctly. because it copied the Word document formatting, and you'll have to go back and fix all the mistakes. And it usually takes longer than it does just to retype the code. Because the quotation marks are different in Word than they are in idle, things like that. I'm guilty of it. I copy and paste a lot because I'm lazy. But just be aware that if it doesn't run after you copied and pasted it from somewhere, probably a formatting issue. Or the tabs weren't the same from one document to the other, and it throws off all your lines. So if you leave something off, that was interesting. If you leave something off, you're going to get an error message. So if I was to type print and I don't put that closing parentheses on there, it doesn't do anything, right? And it's waiting for me to put something else in there. So you get a little box. You're going to get some boxes that pop up to help you finish commands. You're also going to get things that will give you error messages. If I do 2 times 3, and it actually tells me I didn't close the parentheses, right? That's a helpful error message because I know it tells me I need to close the parentheses. You'll get some that are not as helpful, but you will get an error message and you know that there's something wrong. The great thing about most error messages when we get started in our files is it'll give you a line number and you're able to turn the numbering on and be able to tell which line you need to go back to. If I misspell print, I learned to type today. It gives you an error message that is not necessarily as clear. You get a trace back error, most recent call, line, and right. So you have to read down a little further to the bottom to figure out what's really wrong. I usually on an error message start at the bottom looking for a line number and then try to figure out what's wrong if it doesn't very clearly say what's wrong. If you get more than one error at a time, always start at the bottom and look up, because if you fix the last one, sometimes it does away with the others. So you absolutely can work through all of these errors that I just did on your own. The lab, that's what all these things I'm scrolling through are telling you how to do. But I've done them for you at this point. So far in this lab, we did part A. I showed you where to go and download the software. Part B was to show you the shell and where you can test single lines of code to see if they work, but you can't save them because there's no way to save this code and make it an executable file. You can take a screenshot of it if you want to. You can save the shell picture. And then I've showed you what happens if you put in some syntax errors, right? That's pretty much what B is all about. We started idle. We put in some examples of things that work. We went to step 2 and we put in some examples of things that do not work. So now we're going to move to step 3 or C, and we're going to actually create our first executable file to turn into me. So every time you're doing something that you want to turn in, you need to go to File, New File, and create a new file. This opens a separate window. It doesn't say shell at the top anymore. Looks a little bit different, right? And I'm going to tell you, go ahead and do save as and name it. Because if you don't, it's going to be saved somewhere as untitled, and you'll have to go looking for it, right? So let's talk about naming conventions. I need you all to read step A very carefully. I need you to save it as your first name, your last name, and the name of the assignment. So mine would say Tracy Wilson, Lab 1, right? IDLE should put the .py on there for you, but you can put it on there if you want to. So I'm going to come over here, and for the sake of argument, I'm just going to save it to my desktop right now because I know that I'm going to delete this as soon as class is over. You guys are going to turn them in. I'm going to, but you can save them to your desktop too because you're going to find it and then upload it in CourseDen before we leave. Because if you save it onto one of these computers here and you leave, it will not be here tomorrow because these computers reset overnight. These computers in here have deep freeze on them. So every night, sometime before midnight, it's going to reset. So all the extra files that students have put on are going to be erased. The only thing that will be on them is the software that the CS department has installed. So you can't save passwords on these machines. You can't save browsing history. You can't save files. If you do, it will not be here when you get back. And even I have done this. I've saved something on my desktop thinking that, oh, I'll move it to my flash drive before I leave, and I forget it. So if you are going to use these computers in here, which you're absolutely welcome to do, you either need to bring a USB flash drive with you to save stuff to, or you need to make sure that you upload it into CourseDen where you have a copy of it. Because when you get back to your home or your room, you can re-download the CourseDen file there and work on it again. I'm not going to, don't worry that I'm going to grade it early and that you're not, well, I use CourseDen to store an unfinished program. I'm going to grade the last submission, and I'm not going to grade until after the due date. So if you want to upload and download and upload and download, that's fine. Just realize I'm going to grade the last one that you submit. All right, so like I said, I'm going to name mine Tracy Wilson, Lab 1. And the file type, as long as it's Python file on the file type, you don't need the .py. It'll put it on there for you. If you ever have to go on your computer looking for your Python files, you don't remember what you named them, search for .py. You probably won't have that many Python files on your computer. All right, so I saved it. If you saved it correctly, now at the top, it should have your name and the lab showing in the corner. That's how you know you put a name on it. I know it's really tempting to go in and just start typing code. Leave that down there. But go ahead and name it. Just get in the habit of your first step being, I'm going to save this blank file and I'm going to put my name on it where I know that I've got that done. And you're like, why do you keep harping on that? Because every semester that I've taught this class, somebody turns in work as untitled.py. And I have to download them out of CourseDen. And now I just have a huge file full of your work, and there'll be one or two at the bottom that say untitled.py. All right. Step 3 is write the following Python code on the first line. All right, so up here we're going to write print . Now this time, it didn't actually execute the code as soon as I pressed enter, right? because we're in a file, we're going to have to specifically tell it to execute when we're ready to do that. So we're going to press the run button and pick the top option. The shortcut keyboard is F5. It's always going to ask you to save it. And then you notice it pulled us back into the shell window. And if you scroll all the way down, what you executed is now at the bottom. Now, the code you wrote is not there. Just what happened when you ran the program. So good. So since we executed my file and the only line of code in there was a print statement, it printed what was inside the statement. So let's go back to our code. Now we can add comments. Comments are for me and you to tell me what's going on in your code. Comments help you break it into sections, makes it more readable. If you did something that didn't quite work, you can leave me a comment, tell me what you're attempting to do, and I can try to help you. The comments are very helpful, especially if you're sending me screenshots and stuff and you want me to help you figure out where you went wrong before you begin. So we do comments by using a special character. So if you use the number sign or the hash sign, depending on how old you are, that means that we're making a comment. Comments are always in idle red. So if you meant for it to be a comment and it's not red, then you probably left the hashtag off, or you did something not quite right, and you can go back and look at it. So up here, I now can type in my first Python program. And if I run it, I'm getting the same thing because comments don't actually execute. They are just for the programmer, and in this case, me, to see. Why do we need comments? Because I promise you that if you need to go back 6 months from now or 6 days from now and look at your code and you don't have comments in it, you're going to have forgotten why you did something. Or you might forget what that variable is actually holding. So they're there for developers to use and getting, because you can pick, in the real world, you're likely to take on a project that somebody else started. And I assure you, if you get handed somebody else's project and it's not commented, you are going to severely dislike whoever worked on it before you. Because they generally don't still work for the company. They, got a promotion or a better job somewhere else. So it's not like you go to their office and ask them what they meant. Sometimes you can, but not always. And then you spend hours going back to the code trying to figure out what their logic was. Absolutely. Either that or it shows a very arrogant programmer because they decided, this is my code. I'm not going to give them the steps they need to use it after I leave. Don't be that person. Don't be the person in the office that everybody goes, you don't comment your code. Comments. Get in the habit of it now, and it will save you a lot of heartache as you move forward, especially if you plan on doing this for a living. Mine are going to tell you where I want them, just because I want to get you in the habit of it. So what I usually see is most places have a standard that they'd like to enforce. It's not easily enforceable, but they'll have some guidelines they'll give you. If you move forward into 1301, which is the Java course, there's some things that the professor there will say, you have to comment this, you have to do that. And so you'll have some guidelines to follow. What I generally do, if it's something that I'm working on and not a quick example for you guys, is I use comments to break up sections. So in mine, It'll say something like, put a comment that says part 1, comment that says part 2. You may not have to explain exactly what you're doing, but visually that breaks up where each section is. It makes it easier to find and go back and forth. Now, here's the question that nobody asked. Am I going to grade you down if it's not commented? Yes. Why? Because you won't use them if I don't. I've taught a long time, and if I don't make it a requirement of your grade, they will start out really strong with comments, and by the second or third assignment, I won't see as many. And then by the time the first project comes around, there won't be any at all. So we're going to, it's not going to be a huge part of your grade, but it's going to keep you from getting 100% if you don't have your comments. So we've gotten down to step 6. We've added a comment. We ran it. You can, like I said, you can use the shortcut key like F5 to run programs, or you can go to the menu and do it, whichever is easiest for you. It is going to ask you to save it every time unless you've saved it before you ran it. Either way, every time you run, it should have saved. And I'm going to say this too. Save frequently. There's nothing worse than having worked on a project for an hour or so and the power go out and you go, oh, I haven't saved in a long time. And now you've got to rewrite code. You got to remember what you did. So it doesn't hurt to click the save button multiple times. It's always going to be there, right? It's not as big a deal for you guys as it was in the dark ages when we did code for hours. But I have found that students that came out of K-12 recently and used a lot of Google Docs and Google products have gotten used to that autosave. Well, most things don't autosave for you, so get out of that habit and start saving things again. It's just a good rule of thumb, even in doing emails and stuff and Word documents. All right, so now step 7, we're going to do some math. In your program, this file over here, we're going to add in some more code. There's a couple of comments and there's some statements, right? So everybody's going to add this to their file. So we're going to do some math. I'm going to put a blank line in because it makes it easier to read. Yes, sir.
Between the number symbol and my first Python program, are you pushing the tab?
No.
Space.
It's just space. The tabs usually start a line. You'll see as we move forward. We're not using them today, probably. So blank lines are ignored. So if you want to put a blank line between sections to make it more readable, do it. That's fine. So we're going to do some math. So we're going to put another one in and we're going to print. This time I put the 2 times 3 inside of a print statement because I want the results to be printed to the screen when I run it so I can see it, right? If I didn't do the print, your program would do 2 times 3, but it wouldn't display it the same. If I put quotes around 2 times 3, then it's going to print out the equation. If I leave the quotes off, it's going to do the math. So I'm going to do it both ways just to prove that point. You don't have to, but I'm going to. So if I run this now, it prints out hello. It prints out the results of 2 times 3, and then it prints out the equation because that's the 3 lines of code I have in my file. You have a question? No. Just checking. Yes,
So when you push, so when you do print, it's gonna print the equation plus the answer.
No. So what it did is it printed this line, which is hello, then it printed this line, which is the answer. Then this print statement prints the equation. So each line did something separate. But because we didn't format our output, it's just going to put them in a row right under each other. Does that make sense? Now, there is a way to print the equation and then have the result put at the end. And we'll get there. We're built into that. All right. So the next step has us prompt the user for their name. So remember last class period, so we needed variables, right? So I can prompt the user to enter their name, but if I don't have a variable to store it in, I can't use it again. The name's just gone as soon as they enter it. So I'm going to create a variable, and creating variables is extremely easy. You just put in whatever you're going to call a variable and with an equal sign next to it, and you've created a variable. So in this case, since I'm asking for a name, I'm going to make the variable name. Name is equal to whatever the user inputs. Now, I have had students that are extremely literal when they're reading directions. And when it says enter your name, they change it to whatever their name is. Don't do that. If it's in quotes, type it exactly as you see it. So if I do that, and then I want to print the results out, I can do print hi. So this line is going to print whatever's in the quotes. And because I separated the quoted portion with a comma and give it the variable name, it's going to print whatever's in the variable. So when I get done running this, it should say, hi, Tracy, hi, Bob. Whatever they enter, the user entered should replace name because it's going to empty the variable when it prints, right? It's not really going to empty it. It's going to use the value in the variable and print to the screen. So if I run it now, I can enter my name, and it tells me, hi, Tracy. Now, it printed the other lines too, because they're still in the file. But the last portion is waiting on me to enter a name. If I ran it a second time, I could enter my husband's name. And it will tell him hi, right? Yeah, my husband's name's Mark. It's okay. No, he doesn't have the money for it. All right. Questions? Yes, sir.
Just to clarify, we're not putting our name in the quotes.
You're not putting your name in this file. When it comes over here, you are putting your name. So your name should not appear in here at all.
But it should appear in the shell, or do we have to type it into the shell?
You have to type it into the shell.
So once we run it, we type it into the shell.
And you don't have to type your name. You can type anything. So if I ran this one more time, I could. It's going to just feed you back exactly where it's print. You type. Does that make sense? Because users don't always follow directions. Did that help? Okay.
There should never be like a space.
What? Now, when I type here, you can put it, it's going to take in the spaces. Here's a very important fact. Computer science and programming sees a space as a character. So if you type a space inside the quotes, the space will be there. If you type a space when you do an input value, it's going to save the space because space is defined by the computer as a specific character. Does that help? All right, so are we good so far? Everybody have a program that prints out hello, 6, ask you a question, and you can put in input. All right, where are we stuck? If you have a space inside the command, you might be messed up. Yes, sir.
So mine's not saying hi back when I run the program or whatever. What would I have missed?
It's a very good question. Not saying hi back. I think it is. Take this. We're Bradley out. Yeah. Back over there. Come on in. Oh, well, that's it. Yeah, that's great. So your name should not show up here. You should be asking whoever uses your program to enter the name. So your name, they will enter the name. Type your name
Oh, right here.
right here,
Oh, so this is.
where the cursor is. Type your name. Yeah.
Okay.
Now go back over here. And just type. There you go. All right. So I'm gonna keep moving. I will get with you individually if it's not working and work on each individual one, okay? But I want to get this video done for my online students. So if we go back over here, your code should look like this in the file, and mine matches, except I have this extra line here. We are going to add one more prompt, or we're going to ask the user how old they are. So prompt the user for age. Age is going to equal the input from the screen, answering the question or the command. And then I'm going to print out now, you notice I put a blank space between my quotations just to make it more readable. Do you have to do it? No, but it makes it more readable. So now I'm going to enter my name. I'm going to enter my age. And it should print that out. Make sense? Yes, it's impolite to ask a lady her age, but huh? Yeah, you don't know if they're giving me the right answer or not. I did, so I don't care. I'm old. It's okay. So now I can go back and follow the rest of the directions. I can delete the 3 and the print line, and it'll give me an error. So if I took that out, and run it, I get a syntax error. And I can go over to the shell. And nothing happened, right? This is what happened last time. Because I've got an error, is nothing's going to happen. So you can come back here and it highlighted where the error was, and you can put in what you need to fix. Right? Now it should work again. Now, why are we using variables and not just hard coding our name in as a print statements? Because it makes it reusable. Now I can ask any user their name and not just print out my name. So when you turn your code in, I'm not going to type your name into it. I'm going to type some other name into it to make sure you didn't hard code the desired result. Hard coding means that you put in exactly what you wanted to say instead of making it reusable. Do I have sneaky students do stuff like that? Yeah, but I'm smarter than they are. I've graded a lot of papers. All right, so I took the number out, I ran it, I put the number back in, ran it again. You can delete the quotes off of hello in the print statement. And when you run it, you get an error, a runtime error, because Python thinks hello is a variable, but you never defined it as a variable, so it doesn't have anything in it. That makes sense? Then you just go back in the code and fix it. Go back over here and put them back in. So basically, the last part of this is just having you mess up the code we already wrote, where you can see what some of the errors look like. If it's a syntax error and you're missing a number or you're missing a parentheses or something like that, it'll highlight it here while you're typing or when you get ready to run it. If it's a runtime error, it'll pop up in the shell. Does that make sense? Because hello without the quotes technically doesn't violate the Python rules, because hello could have been a variable, but when it ran it, it realized that there is no variable called hello. I see some confused looks, so we're gonna keep working on this until everybody gets it. So we're down to step 10. We did the age. You can execute this and play with it as much as you want to, but that's the entire program. Now, to submit your code, you're going back to Coursed, right? So you're going to go back to Coursed. And I may need to make it look like a student. Let's see. Mine looks a little different than yours. View the student. All right. So if I view it as a student, I can go either in under content where I was, or I go to assessments and to assignments, lab 1. And there's a box down here where you can give me comments, but mostly I just need you to add a file from my computer. And if you click the upload button, it will let you go search for it. I'm going to upload mine and press add. Now, when you see the file name here, you're not done. You still need to press the submit button. And now it's submitted to me. And if I look at it, it says submissions, and it will list all the different submissions. So you can submit more than once. If you're using it to save your work until you get home, that's fine. But now I can download the file when I'm ready to grade it. Or you can download it when you get back to your dorm room or your home, and you'll be able to pick up exactly where you left off. All right, so before you leave today, I want you all to submit something just where you have practice submitting the lab. I prefer you not leave until you've actually 100% done the lab and get it submitted. I'm going to stop recording now and go around and answer individual questions for anybody that is still stuck and not ready to submit. If you've got it done and you've submitted it, you are free to go.